Peter introduced some of the background of the ventilative cooling, so I will very shortly go through the background. The development towards low energy buildings or nearly zero energy buildings leads to a decrease in the heating need, but often also to an increased need for cooling. And as I will illustrate in a few slides, this is not only in summer, but it's actually all the year. And from many of the post-occupancy studies that has been done in these nearly zero energy buildings, we can see that elevated temperature levels are often a reported problem. In reducing the energy need in buildings, we have a large focus on reducing the heating need, and this means that sometimes we do not address the cooling need in the same rigorous manner, and probably also the solutions we have available to develop more energy efficient cooling solutions are less than in other areas. I will here give an example of a nearly, or actually a zero energy building that was a residential building that was constructed recently in Denmark. And the next slide shows, you could say, the recorded temperatures during the first year of operation. We have the operative temperature in the living room of this building as a function of the running mean outdoor temperature. And as you can see here, if you look at the temperatures, that these are actually more or less at the same level, both winter, which are the blue ones, and in spring and autumn, and in summer, which are the orange ones. Actually, you could see that we have even higher temperatures in winter time sometimes than we have in the summertime. The difference between this type of building and the buildings we are used to design is that when you look at a very well-insulated and airtight building, the heating and cooling dependence on the outdoor temperature becomes less, but the dependence on solar radiation increases. So this means that the heating and cooling need is more determined by the availability of solar radiation than actually the outdoor temperature level. This gives, of course, a better potential for utilization of ventilative cooling, because you have a need not only in the summertime, but actually during the whole year. The next slide shows that the importance of control and operation. This building has the opportunity to apply both solar shading as well as ventilative cooling, and the lower two figures shows the indoor environment in this living room in year 1 and in year 2. Year 1 was what you saw just before at the previous slide, and year 2 was then the following year, where both the system was commissioned to work better than in the first year, and as well the users were instructed in how they could adjust the shading and the ventilation to improve the conditions. And what you can see is that it's actually possible to improve the comfort conditions in this living room quite considerably from year 1 to year 2. So the main conclusion here is that in this type of buildings where we have technologies like solar shading and ventilative cooling, commission is critical, because the performance depends very much on the control, and also the interaction with the users are very important to make sure that it works properly. So why do we have an overheating problem? For residential buildings in cold and moderate climate, it's a new and increasing problem. Peter mentioned that we have worked on ventilated cooling for many years, but we have mainly focused on warmer climates and mainly focused on office buildings where we have high heat loads. But it's new that even in cold and moderate climates, this is a challenge now. For residential buildings, we have often very few standard solutions. And we have also users in cold and moderate climates may also have limited experience about how to handle overheating problems, and some of the solutions applied are not so well adapted to practical use. A few words on ventilative cooling. It is application of outdoor air to reduce the cooling mood in buildings. And when we speak about ventilative cooling, we both utilize the cooling potential, but we actually also look very much into the possibility to increase the air velocity, and in that way enlarge the, you could say, limits for thermal comfort. And ventilative cooling can be driven by natural means, by mechanical means, or by a combination. And because ventilation is often already present in most buildings, either through mechanical or natural systems, it's not, you could say, a big extra expense to also utilize it for cooling. Now, a little bit more about the project as such. We have 4 different objectives. First of all, we are looking into the present methods and tools for predicting cooling need in buildings, predicting the performance of ventilative cooling and the risk of overheating. And we will develop, you could say, these solutions and improve them. Then we will give some guidelines to ensure a better integration of ventilative cooling in our performance calculation methods, as well as in our building regulations. We will look into how existing ventilation solution can be improved, so they can also be used for cooling purposes. And we will look into what are the requirements and needs for development of new solutions. And the new solutions, of course, should both be able to handle comfort conditions, both in, I would say, in summertime, where we maybe need quite large flow rates with high outdoor temperatures, but also winter conditions where we might have a very cold outdoor temperature that we need to provide cold air in a lower amount, but without giving the risk of draft. So this is a new challenge to the systems. And then finally, we want to demonstrate the performance of developed solutions through a number of case studies. The outcome of the annex very much follows the objectives. We will develop some guidelines for application of ventilative cooling for their operation, for the design and for the operation. We will give some recommendations on how to integrate ventilative cooling in legislation, in standards, and in energy performance calculation and verification methods. Presently, it's not very well covered. This is a barrier for the application of the technology. Then we will develop new ventilative cooling solutions, including control strategies, as I mentioned before. That's very critical. And also demonstrate and document the performance of such systems and case studies. A little bit about the organization of the annex. It's developed into 3 different work packages, one on methods and tools, one on physical solutions, and one on case studies. The one on methods and tools will look into these prediction tools, design tools, and methods, and see. And as ventilative cooling is very important in the first, phases of the design of the building, because it's very closely related to the design of the facade and the design of the construction and the availability of thermal mass and so on. We need to look into how we can develop methodologies for the first phases in the design phase. In the solutions, we will look into both improvement of existing systems for cooling purposes, and as well look into the development of new solutions for different climatic conditions. And finally, we have the Subtask C, which will be on demonstration of the performance in case studies. Here you see the number of countries which are presently participating in the project. We have 14 countries, mainly from Europe, but also Japan, China, and the US is represented. You can also see the leadership. I'm the operating agent, and we have Subtask leaders for the different work packages, and you can also represent it from Switzerland, Italy, Austria, Greece, and China. And of course, if you are interested in the annex or interested in some of the activities in the Subtask, you are very welcome to contact these persons. You can find contact information on the website. The first outcome of the work will be an overview report or state-of-the-art report on ventilative cooling. This slide shows the different chapters, and we are presently preparing the content of this report, where we try to collect all the existing information on ventilative cooling and summarize it in a report. And we expect that this report will be available for publication by the end of 2014. Yes, thank you for your attention. Looking forward to answer any of your questions. Thank you.